Hello everyone, I am Tanuja from ENH iSecure and thank you for joining the demo session. Now we will be demonstrating Crowdstrike integration with Okta. As you may have seen in the overview presentation, the integration empowers organizations to make smarter and real-time access decisions by combining the Okta's IAM capabilities with CrowdStrike's device security insights. Let's move straight into the demo to see how the integration works. Consider this as a scenario when a user attempts to access a company resource from his machine. Okta first checks the security posture of the device by leveraging signals and risk scores from CrowdStrike Falcon. Based on the device risk profile and configured threshold limits, Okta can allow, deny, or ask for additional authentication, ensuring only the approved device could access the resource. These controls lets only trusted users on secure devices can access the entitled applications. Let us go through the integration aspects. As we are in the admin console, let me navigate towards the security section. Then I will tap on the device integration section. Within device integration section, navigate to the endpoint security tab where we can view all the existing endpoint integrations. To add a new one, let me click on Add Endpoint Integration. I will choose CrowdStrike from the list of the vendors. And select Windows as the platform. This setup allows Okta to receive device trust signals from CrowdStrike's endpoint detection and response. Next, followed by onboarding the endpoint by installing the Okta Verify and CrowdStrike EDR agents in the endpoint. To install Okta Verify, let me begin by clicking the FastPass button and by selecting the download here option. The download begins. Once the download is complete, proceed to install the application. After the installation is complete, by simply clicking Open Okta Verify, we'll launch the app and begin the enrollment process. Let me click on Get Started button to begin the setup process. This will be redirected to the Okta authentication page. Here let me enter a demo account. In this use case, I will use Mark Henry credentials. This will send a verification code via email. And let me enter the code to complete the verification. Once verified, the account will be added successfully to Okta. Allowing us to use it to secure the authentication process when accessing the entitled applications. Now let me take this to the second component, installation. This is a test mission picked up for this demo, and installation happens as follows. The installation agent is downloaded and we need to run the program to start the process. During installation, We will be prompted to enter the unique customer ID, which should be available from the download or can get that from the IT support team. Once we enter the customer ID, tap on the install button to process the setup. This will allow the Crowdstrike Falcon agent to register the device and enables protection and monitoring capabilities on this device. Post installing the Falcon agent, we need to customize it as per the Okta guidelines for installing the integration plugins. Let me begin by copying the PowerShell script provided in the Okta portal for security plugin integration. Let me open the PowerShell console. And use the dir command to display all the files and folders in the current directory. Navigating to the downloads folder using the cd command and running the dir again to ensure the agent file is present. Let me paste and execute the copied PowerShell script in this location. After running the script, open the command prompt. To check the Falcon sensor service status, enter the below command. After that, let me enter this command. To register the agent using the Crowdstrike customer ID, which was copied while downloading the agent. Once the installation and service verification is complete, log into the Crowdstrike account to access the Zero Trust Assessment dashboard. Here we can go through the security scores of each device, including the OS assessment score, sensor assessment score, and an overall assessment score. These scores provide insight into each device to meet the organization's security requirements. and each entity is categorized by priority levels such as high, medium, or low. By analyzing these ZTS scores, we can identify areas that may need attention and use this information to define and implement security policies by setting conditions and automated actions based on the risk level indicated by the ZTS scores. This process helps us in ensuring that all endpoints are continuously monitored, protected, and are compliant according to the organization's security standards. To enforce security, let me start by navigating to the security section and select the authentication policy. Let me click on Add Policy and name it Crowdstrike EDR policy. Next, adding a rule to this policy by clicking Add Rule and let me name it Crowdstrike EDR rule. Now let me configure the rule by setting the user type and group to any, and the device state is registered, device management is not managed, and risk to any. In the custom expression field, let me enter the below expression to ensure that only devices with a ZTA operating system score of 60 or higher are allowed to access. Set access to allowed and require user authentication via possession factor, making sure to prompt for authentication every time. Then let me edit the catch-all rule to establish implicit deny statement. After saving the policy, let me assign this to a sample application. To ensure only the entitled users and compliant devices can access it. Let me open the sample application and navigate to the assignment section. Here I will assign Mark Henry to this application. Before testing the policy, let me access the CrowdStrike admin console to view all the devices that are onboarded. I can see the test virtual machine in the list and got an assessment score of above 60. Based on the authentication policy, this device meets the necessary security requirements and should therefore be allowed to access the application. Let me open up the command prompt to verify the host name of the test machine. From which the test is being carried out. As we can see, the hostname matches, and let me initiate the login process using Mark Henry's credentials. Upon logging into Okta using Mark's credentials, user can now see the entitled bookmark application on his end user dashboard. Let me click on the developer blog to access the application. As per the security settings, a prompt appears asking me to sign in with FastPass. By selecting the FastPass option, a consent prompt appears to confirm the identity upon authenticating it. Okta verifies the session through from enrolled device signals and FastPass credentials. Since the device's JTS score is above 60, which satisfies the authentication policy requirements, user Mark is granted access to the application. Let me take the session to system logs to verify the session through logs. The system logs indicate that Mark Henry from the registered device attempted to access the application. The authentication process triggered a multi-factor authentication challenge. We have successfully completed it. From these logs, we can confirm that Mark Henry was able to sign into the application. This sequence demonstrates that according to the current authentication policy, Mark Henry's access to the application from the test virtual machine was permitted. When attempting to access an application using another device which has an OS ZTS score of 47, which is below the required threshold of 60, the application access should be denied according to the authentication policy. Let me open up the command prompt to verify the hostname of the second test machine from which the test is being carried out. As we can see, the hostname matches, and let me initiate the login process using James' credentials. Let me simulate that from another machine using a different set of credentials. For this, I have picked James and he logs into Okta from the second test machine. He is able to view the end user dashboard. However, when he tries to access the bookmark application, a prompt appears requesting him to sign in with FastPass. After James selects the FastPass, a consent prompt asks him to confirm his identity. Let me confirm the prompt. Despite this action to the application is denied because the device's OS ZTS code does not meet the policy requirement and was denied by the implicit deny rule. Let me confirm that as well from the system logs. Here James Mary attempted to access the application using the second test machine. But the authentication process was denied as it didn't meet the evaluation criteria. This indicates that under the current authentication policy, James is not permitted to access the application from the second test machine. This shows that only trusted users on a secure devices can access the entitled applications. This approach strengthens the organization's security posture and aligns with the zero trust security model. This wraps up our session. Thank you for your attention, and I hope you found the information helpful.